So we have an absolute value. Well, what is absolute value? It is the distance from 0. And distance is always what? Always positive. So in this case here, it would be distance from 0, which would be always positive. So this is an absolute value. The actual would be, if I was going to write this, would be f of x is equal to the absolute value of x minus 3. This is what the function really looks like. Okay? If I was writing it down. You get your ID? Yeah, you got it. You got it. All right, so what we're going to be doing, guys, here real shortly is we're going to be taking this right here and write it into this statement, okay? And as you can see, we're moving it to the right 3 units, okay? That's what this absolute value has done. It's moved to the right. It's a transformation. You might know what this thing's called right here in the middle? A little point. Geometric term, vertex. You might know what this thing's called right here? Right down the middle. It is a line of reflection, but we call it the axis of symmetry. Okay? There's a few things. Okay? Now, evaluations. All right, so I'm going to go over these evaluations here. The evaluation for f of 5. Remember, this is saying x is equal to 5. What's my output? What's my y? That's what I'm looking for. So there's a couple ways you can do that. Graphically, we can go right to 5 and we can find it. So my output would be 2. That's how you do that with the graph. Now remember, you can do both ways. So now we can also do it with domain restrictions. You take your 2 and you go up here and say, is 2 greater than 3? It doesn't work there, so you scratch that one off. And you say, all right, is 2 less than 3? Yes, it is, so it fits in that one. So I'm going to plug in 2 into that equation right there. That's going to give me what graph? Oh, I said 5. Why did I say 2? 2 is in my head. I'm looking for 5. Sorry. Take this back. Chalk that up as a Monday mistake, which is a Wednesday. That's all right. We're still good. And Rhett and Luke would say, we're still good. All right? I had that game. You have that game? We're still good. Never mind. So x is equal to 5. So it's 5 greater than 3. The answer is yes, so it goes in this one. So you put your 5 right there. That's how you get 2. Okay? Done. Okay? It doesn't fit in that one. 5 is not less than 3. Then we'll know. All right? So go ahead and let's do the next one, which is 1/2. So f of 1/2. All right? Well, 1/2 happens to be right here, this weird number. So where does 1/2 fall? Is 1/2 greater than 3? No, it fits in this one, which is less than 3. So we're going to plug into that one. We have to plug a half in right there. So I'm going to come down here and write this as negative 1/2 minus 3 over 1. So you need to have a common denominator, which would make that a 2, which would make that a 6. When I subtract, I get a negative 5 over 2 with a negative out front, which will make that a positive 5 over 2. Okay? And as you can tell, 5 over 2 is 2.5, which is about where we're at right there. Okay? My output should be at 2.5. It's not exact. See, my graph is not given. I would say, oh, it's at 2. I got it wrong. Okay, it is at 5/2. So when you deal with fractions, you're going to actually have to do it algebraically. Okay? Go ahead and attempt number 2 and 3 there. Everybody in here took the test on Friday, so I'm not going to make it. Good. Nice. I don't know if we're going to use it that much in this unit, but you have one. Ready to cover this? Actually, good job. Did you get it? But if -4. Oh, look at the solution. No, look at that. No, a solution, like, that's a no solution. So, that's a no solution. Don't try.
Sorry, I'll make sure. There has to be
That's a no solution. Or I don't know. All right, so this one here, we are going to go down 1. I have a positive slope. So hopefully you have this one greater than 1, which is a solid dot going this direction. The second graph is starting at, if you wanted to, some people actually distribute the negative and then put it in suffering step form and do this and then they have an open circle going this direction. There we go. This one here, that one is, again, we're going up 4. I have a positive slope. So it should be a solid dot at -4 going to the right. This one is negative x minus 4, starting at -4. And so I have an open circle, and it should be going to the left. So you should have 3 V's. Now, again, this would be f of x is equal to the absolute value of x minus 1. This is what that function looks like. I am moving it right 1. That is what you're doing with this absolute value, moving to the right 1. This one, I would have f of x is equal to the absolute value. What do you think it's going to be? It is going to be x plus 4 because we're moving it which way? Left 4. Okay. Now, looking at this one right here, at g of 0, that's when x is equal to 0. Well, that's pretty simple. It's on this line right here. I think it's just going to be 1. If you want to see it algebraically, remember, you go over here to your restrictions on the right side, and you go, is 0 greater than 1? No. Is 0 greater than or less than 1? That's it. So it's not this one, it's this one. So I plug in 0 right here, I get -1. Well, that's a positive one. All right, on the second equation, on the second one, we were going 5 over 2. So I'm doing 5 over 2, which is roughly 2.5. Actually, it's exactly 2.5. And 2.5 is larger than 1, so it goes right there. So then you should do 5 over 2 minus 1. Well, that's really 2 over 2, which gives you 3 over 2. Questions? All right, now we're doing f of -2. F of -2, or h of -2. Sorry, this is equation h. And that is right there. I can see it on my graph right there at 2. So the answer is 2. -4. That's at 0. It's right there. Questions? All right, I got one for you. What about this thing? What's going on there? What's that all about? What do you try in? What's that saying? Oh, that is y equals 6. This is y is equal to 6. What is that? That is a line at 1, 2, 3, 4, 5, 6. Which is this line right here. Oops. Let's see if I can draw a little better. Like that. Now this green line intersects it right there, right? At -3, right? And the red line intersects it at +9, correct? So how many solutions do I have? 2. So I would have -3, 6 is a point. 9, 6 is a point. You may ask yourself, how does this happen? Well, there's a song about that too. This is the absolute value of x minus 3 is equal to 6. So we are going to be solving absolute value equations that look like this. Okay? As you can tell, we end up having a positive one that has a positive slope, and we end up with one that has like a negative sign. Okay? So if you think about it, you just do x minus 3 is equal to 6, and then negative x minus 3 is equal to 6. And you solve. If I add 3 over here, I get x is equal to 9. That's where that 9 came from. Over here, if I go negative x plus 3 is equal to 6, subtract the 3. Negative x is equal to positive 3. So x will equal -3 in the end. That's where that -3 comes from. So we are going to be solving absolute value equations that look like this. Okay? Now, I want you to notice, all right, what's really going on is you guys had stated earlier that absolute value is always positive. Take a look at this line right here. I'll draw it as a dotted line here. Look. let's just say my first equation. What's that thing up on me today? You gotta jump out. So it is this line right here, correct? What's happening at this point right there? What's happening at your vertex to your line? My y values are all what over here on the side?
Going up.
They're all positive, going up. What is happening here? They're negative. What does it happen to say when you take an absolute value of a line? What happens? Your negative will turn what? Positive. So this line over here, this negative part is flipping. It's got a reflection. You're doing a reflection. That's what this is stating right here. Remember I talked about ROX? Guys, here, that has no ROX. That has an ROX, it's a reflection over the x-axis. You're taking that half of that line and you're flipping it to positive, and that's why you get this V. Okay? It is the same line. It just happens that we have a reflection in it. That's what the absolute value does. All right? It takes that, and at the vertex, you take the reflection. That is what this is doing. Okay? So that's all of these. It's saying positive slope, that's the one with the negative slope. Because when you're reflecting it, it flips it over, gets the line. It's special, it's one of the special functions. It's very unique. Absolute value is very symmetrical, and so when you do a vertical stretch and you do a horizontal compression, they're the same thing. Okay? So you can treat them as slopes. So we'll go over that when we get to those, which is soon. Very, very, very soon. All right, so looking at this one right here, I've got a blue line right here, correct? It has two solutions. Can I draw a line that would create it to only have one solution? See, that green line is only hitting one spot, correct? But when we do this and we work on these algebraically, how many solutions would I have? It's gonna ask that one, it's gonna treat this one. Guess what about that pink one? It doesn't exist. It's an extraneous solution, which means it's an extra answer that doesn't exist. Because we flipped it, it moved it up. It didn't. We don't work with the one that's underneath. So you're going to solve an algebraic system. We're going to have a piecewise, and we're going to check your solution. So you would take that and check it in these to see if it works or not. Okay? So there's a test to that. So we have to be able to, number one, we're going to take this. We're going to write our piecewise. It looks like this. We're going to solve our equation, and we're going to check it to that piece. So all of this is coming about. It's going to happen. So if you can understand pieces and parts of it and what you're dealing with, it'll make it a little bit easier, okay? But it is really just a line intersecting another line. That's what we're trying to do, find the intersections. But what makes this line unique is that we're taking the reflection of half of it. We're flipping up, making a V, so you can intersect in two spots, intersect in one spot, and so on and so forth. And so you get false answers because of that flip, all right? Enough on that. Let's go into our notes now. I'm going to hand these out to you. Well, actually, let's go over if you got any questions on your homework. While you're getting your homework out, if you got any questions, you can ask it. If you don't have any questions, fine. My question to you is, do you guys know when your homework is due? Today, right? Your homework packet's due today, and then we had our 5-6 week, but it's not due till the Ides of September. That's September 15th. That's like the middle of the month. After parent conferences are over and everything. You guys have like a 3-day week this week and then a 4-day week next week. Can you imagine that? And I get to meet your parents. It's so exciting. Have your parents come in. Huh? But now that here's more active. All right, so I have finished grading your test in here. I will post those today in Aspen, so you'll have those. You can take a look at them sometime you did. there are a handful of you that are still not multiplying correctly, right? And it's very, very few, okay? But we need to figure out, and I want to put them together. I'm gonna go through them again before I hand them back, because I'm not gonna hand those back till Monday of next week. Before parent conferences. That makes sense, okay? So we need to make sure that we know how to multiply. That is one thing that should be almost a given at this point in time. But if it's not, it's okay. We can fix that. And the word problems, so you guys need to make sure you know how to do word problems. Some of you guys did really well, so kudos to you. Good job. All right, so going back over homework. Any questions over your homework? Here are all transformations. Remember, in this case here, we're taking this parent function and we're transforming it. So if we're going to transform it, this is going to move to the right 2. Again, it's easier if you would just draw a dotted line at right 2 and then plot your parent function points on your new grid. If you choose to, I don't care. You can do a table values, and you can go ahead and add 2 to your x's on all of those as well. You need to be able to do it from a table as well, because I'm not quite sure how the state's going to represent your data. But if you can do it here, then you should be able on the graph. When you get into trig and pre-cal, they're really just looking at, are you in the right shape? Okay? So you're going to do your transformations and make sure you're in the right. So we do it all in the graph when you're in trig and pre-cal. They don't use the tables. Okay? So make sure you can do that. Here is piecewise. We're going over this. If you didn't get this one right and you didn't know what to do on this one, today's notes will take care of that. If you already know how to do it, then you know how to do today's notes. Just go through and practice all the stuff we're doing today. And you can have your homework out to next to you, and you can work on your homework at the same time if you need to. All right, so you're going to be able to graph and write the equation. This is what we're doing in our homework today. Our notes today. So again, you have homework. It's all about this. Anybody notice anything special about number 2 in tonight's homework? What is that? That is an absolute value. It is. Okay? This is an absolute value. Now, I'll give you a little heads up for those who are really strong with this. This is the absolute value equation, right? There is something, you see that x is multiplied by 3 right now. I call it not a clean x. I need an x to be clean. So we're going to separate those when we're doing our transformations. The 3 is going to go here, and you're going to separate that. Now that's going to be a negative sign. So what number would have to go here for that to be true? That would be a 2, correct? That's a 2 right there. Then that is 2. This graph is moving to the right 2 units. That's why those are 2s. My vertex is at 2. Okay? So 2, 0 is where my vertex should be in this particular problem. Okay? So we're going to go over transformations of absolute values as well. So that will be involved in that when we get started. I think tomorrow we'll probably get started with this. Okay? There is what we call a horizontal compression of 1/3. It is lying to me. We will flip that over, make it a 1/3, and 1/3 means it's getting compressed. Horizontally, it would be this way, which means that it would be up 3/1. So if you work on your homework tonight, that's what that particular problem is. Okay? Jumped ahead. That's all right. It was fun. Anybody have any questions? Did you guys go to Dunham Sports this weekend? All the kayaks, they were actually having a sale on paddles there for Labor Day. It was quite an ordeal. Or that was like, it was an ordeal. Word. That was pretty cringe. Sorry. Moving on. Let's take a look at our notes. All right. So, as you can tell, I already have these kind of labeled from left to right. This is number 1, this is number 2. It will help me if you would actually do this when you're writing your functions over here. All right. We're going to write this as a piecewise function. We have f of x equals. All right. We need, what do we need, Peyton, in order to write an equation of a line? Yeah, you need a slope and a point. So that would mean that we need to use point slope form, would probably be the best thing for you. Correct? So that is that form right there. All right. So, Carter, what is the slope of number 1? It is 0. What is? Do you have a point? Or do you need one? Because if your slope is 0, then what's the equation, you know? And the equation is whatever this is right here. What would that line be? Y equals 2. So we just write a single number over here. You don't have to put y equals because the f of x already represents that, correct? All right. So, Carter, as we get our slope, this was a tricky one. Anytime there's a flat line, it's a tricky one. It's a single number. Okay, there's no x involved in it. Then you're going to put a comma, and then we're going to talk about how wide it is, the width, which we call domain restrictions over here. How wide is that line? Knox, how wide is that line?
It's 2 blocks.
It is 2 blocks. From where to what?
From -4 to -2.
So we write down -4 over here, the smallest number, and then we write down the largest number. Okay? Now there's 2 ways you can do this. I'm going to show you both ways. One is just writing in what we call interval notation. If it's a solid dot, it is a bracket, so it's equal to, so it's just like that. If it's an open circle, it's a parentheses. Remember that? Now, if I'm using an inequality, I'm going to go from -4 all the way to -2. The x goes here. Okay? We always use less than symbols, which are like this. It is ignoring the -4. That's the smallest number. It wants the largest number, which is -2. But if it is solid, then if you have to draw more, you have to write more. Okay? So it's an equal sign. So you can write it as either one of those, Carter. I don't need both. I just need one. Does that make sense? I'm just going to use interval notation. Now, Kylie, what is the number 2? What's the slope of number 2? So m is equal to 1. What point are you going to use? So she's going to go ahead and pick the endpoint, -2, -7. Beautiful. And so then you write that as 1 parentheses x.
Oh, sorry. -7.
And then what goes x1, which is, that's your x1. This is your y1. So minus a -2, then -7. Make sense? And what happens to the minus minus? So you always take the negative, in this case here, when you're using -7, -2, you always take the opposite, and that's why it's going to be a plus. Okay? Aubrey, how wide is that line? Huh?
-2 to infinity.
-2, and then she put infinity down. All right. So it would be a parentheses around infinity for sure. What about the -2? It does have a bracket. How would you write that as an inequality? What do you think, Overby? We'll write the inequality for that one. We have a -2. We have an x. So the question would be, what symbol do we write? Is that your greater than symbol? Which is correct. Greater than or equal to. There you go. Now, to help you out on this one, so if you're kind of confused on inequality, when you're writing this as an inequality, remember it's trying to ignore the -2. The -2 is the smallest it can be. So again, if this is a monster, it doesn't want the -2. It wants everything that's larger, which is the x. Okay. Now she may have wrote it as -2 and x, and in this case here, she can always remember it's going to be a less than symbol every single time if you do it that way. Okay. You can write it like that. I don't care. That's fine with me. All right. Now we're going to evaluate these. So Peyton, let's take -3 and plug it in. What would you get? Like 2, correct. Not like 2, but is 2. All right. So he took this right here and took the -3 and he plugged it in. Now, 2 things he had to do. If he's doing algebraically, he's going to check these. Where does -3 fall? Is it between -4 and -2? Absolutely. Then it's just that single answer. There is no x to plug it into. Had -3 happened to be in this one, then you got to plug it into your equation to solve. Now, can you plug -3 into both those? Yes. But only one of them is going to be right. Okay, even if I got 3, 5, 6 equations, one single number, one single output. Okay, these are functions. 1x gives you 1y. So if you happen to be on a test or a quiz and you give me multiple values for these right here, you're in the wrong. Unless I give you a y. If I say f of x is equal to 7, now that could possibly have 2 answers. Okay? Now, this one here, as you just said, was 2. That's good. This weekly, what would be? She goes a -2, and you find it to be 2. Does -2, that is not including -2. This one is including -2. Does that make sense? This is a tough question. All right? This one right here is a tricky question. I don't know if you need to put a star next to it or whatever. I am definitely going to give you this question on a test or a quiz. Okay? Got that, Elijah? Definitely going to ask this question. In this question here, again, I have an open circle and I have a closed circle. All right? In this case here, you have to determine which one it is. That's open means it's not there. The closed means it is. So the answer to this is -7. If I look at it graphically, it is -7. If I'm using it algebraically, -7 falls between -2 and infinity, correct? Or does it not? I'm sorry, -2. Did that earlier today too. -2 falls between -2 and infinity, including -2. So you will take the -2 and you will plug it into this equation right here. So then you would go over here, you would write it down, and you would write down -2 plus 2 minus 7. That goes away, so -7 is my answer. Clear with that? Lydia, help me out with f of 0, since I'm doing so horribly at this. What would f of 0 be? -5 is correct. It is really straightforward. It is right there where the x-intercept, or I should say the y-intercept is. Now, as Kylie had wrote this equation as this one right here, in A block, I asked this question, and Garrett gave it to me as x minus 5. Anybody else write it as x minus 5? Did not use point slope form? Why did he choose that over point slope form? It is less work because what was showing. Yeah, the intercept was clean. It was right there. So it was just easy to go ahead and write the slope-intercept line. And you can do that, okay? And if you spot that and it's a nice clean point, please do that, all right? I don't care. If you wrote it like that, it's great. If you wrote it like that, it's great. I'll accept both, okay? Melody, what is that? What do you think, Mathis? What do you think? -2 is correct. In this case here, I'm going to test it out. I take the +3, and I see where does it fall. Well, 3 is not between here and here. It is between this and this. So then I'm going to plug this in. Now remember, we were using x minus 5 here. You could easily do that. Plug in 3. You get 3 minus 5, which gives you -2. Elijah, what is f of 1/2? You got -9/2. Again, 1/2 does not fall between here, these negative numbers, but it does fall between here. So he went 1/2 plus 2. No. Maybe, did you use that one? Or did you use this? It didn't matter. We'll do it that way. That's going to be over 1. Got to make that over 2, so that's 4/2. That gives you 5. No, messed up somewhere. What's a minus sign? So it gives you 5/2 minus 7/1. Multiply by 2 to each of those. That gives you 14, minus 14. Yes, -9/2 is correct. It would have been a little bit nicer had you used this one, 1/2 minus 5/1. Then that gives you 10. So slope-intercept form is generally easier, right? When you're plugging in values. All right. F of -9. Annie, what'd you get for f of -9? She put does not exist. DNE. Undefined works as well. It has an undefined domain. Okay? Addison, what is f of 15? I don't know. Does it fall between -4 and -2? No. So it's got to be between -2 and infinity. It does exist. So then you just do 15 minus 5, or you can plug it into that one, however you want to do it. Did you guys get 10? All right, let's see. Was there any others down here? That was it? Fun. All right, moving on. Clear the ink and slide on to the next page. Lily, what is the slope of number 1? 1/7. She counted up and then over, got 1/7. What point did you use? You did which one? -5/0, so you went x plus 5. How wide is that there, Mary Beth? How wide is that? Yeah, what we would start with is what? -infinity all the way to 2. Yes, make sure you always have the smallest number on the left side. Parentheses, and what goes on the 2 there, Mary Beth? Bracket or parentheses on that 2? Which one did you say? It is parentheses. Ian, what's the equation of line number 2? Huh? -1. Go ahead and give me the width too. How wide is it? There you go, bracket 2, bracket 3. Murray, what is the slope of number 3? -2? And what point did you use? Guess again. Look at one more time. For opposite that. 4 or 3. It's a Monday. I'll chalk it up as a Monday. Even though it's a Wednesday, it's hump day, but our brains are still mush. Good job. All right? You caught it. That's good. How wide is that there, Madison? Line number 3. What's the smallest it gets? F4. And then how far to the right does it go? Infinities, correct. Now, do you do brackets or parentheses on the 4? It is a bracket, and parentheses always has a parentheses. All right. Okay, Kevin, we're looking at number 5A. What is G of -5? You think it's 0? Yeah, he's right. All right, good job. That was an easy one. Sorry. Hutchins, what about 5/2, man? So anytime you have a fraction, you're going to have to do what with your number? Plug it in. Now we got to plug it into the right equation because we have 3 different equations there. So 5/2 is roughly what? It's exactly 2.5. All right, so we're at 2.5. So we're looking at 2.5 on the graph. 2.5. It's right there. What do you notice? It's just touching that line right there, eh? Which falls between here and here, which means it's just a single number. Stella, what about 7/2? I guess I have to wake her up. 7/2. You're doing F of 7/2. Where would F of 7/2 be? Aha, I like it. Does not exist is correct. 7/2 doesn't fall. It would be to the right of this one, but to the left of this one. 3.5 is here, and it's right here as well. So it is undefined. G of 2. Looking at Cheyenne. G of 2. -1. That's what you said? I mean, I'll go with it. It's a tricky one, isn't it? Graphically, sometimes I'll get students who go right here and I say 1, and then they give me -1. It is only in one location. The open circle, it doesn't exist. It exists there. That's the only place it exists, okay? This will be a tested item. I will definitely have one where you have to jump to get there. I will definitely have one where there isn't an existence, okay? Definitely probably have one that is a fraction that you have to plug in, okay? And all the others are pretty simple. And all right, so we got one more, which is G of 11, and that left it Ellie. So Ellie, taking a look, 11 between these two. -infinity to 2. Does it fall between those? No. Is it between 2 and 3? Nope. Is it between 4 and infinity? So somewhere in there, which means we're going to use this equation. So all I have to do is plug 11 in right there. So -2, and then I have 11 minus 4. Now I'm going to write this work up here, but it should be down here. Okay? Your work should be down there. Okay? Now, Ellie, what does PEMDAS tell you to do? Yeah, and you get? 11 minus, oh, I see what you did. That's fine. She went ahead and distributed. Let's go. Negative 22. I'm going with it. I'm going with it. And then negative 2 times negative 4. Positive 8. Good job. Okay. You finally get it? Mm-hmm. So you get a negative 11. Is your final answer. Okay? Now, I would have, Ellie, I would have went, when you said deal with the parentheses, in my head I was thinking, oh, you're going to do that, make that a 7, which is totally acceptable as well. And then negative 2 times 7, that gives you negative 14. And then you add 3, then it gives you negative 11. It didn't matter. I like the way you did it. Okay? So I did see this video by Howie. I have to show you. Let's see if I can remember how it's done. He said, add those up. I'll let you add those points up. He had a little bit drawn a little more precise than mine. All right, you get your total? How many is there at Houchins? Is there 18?
That's what it was.
Is that what you got?
Yeah.
18?
Twice.
I think I have an extra dot or two. Okay, so you have 18. So how'd you add? What did you add there? How'd you do it?
Oh, so like I just looked like left to right, like down the columns where there's like 4, 2, 5.
5. Okay, so that's what he did. So how did you add them together? Whoops. Aubrey, how'd you add them together?
I went 3, like on the top, plus 4, plus 3, plus 3, plus 2, plus 3.
So she added this. And so the whole point was, who's right? Did it matter? Math is done this way. This is the way math is done. There are lots of different ways to get and achieve an answer. Okay, and the one way is that we had somebody. If I had it drawn a little bit better, I drew it wrong. But he had a butterfly, and somebody was saying, "Hey, I added the butterfly together," and they saw a different way. And so math in itself, sometimes whoa, that was pretty to do. You know, like that was a great way of thinking about it. And so math in itself is pretty. The process is what we're talking about is different for you guys, and that's what's beautiful about it is I get to see sometimes the way you solve it. So like Ellie, she decided to go ahead and distribute the -2, where most of you guys would have said, "Oh, let's just deal with what's inside." Okay, and that's what we talk about. The process of math. It is unique for everyone. You see it differently than you see it. Then you see it differently. And so, but the thing is, if you share your idea of how you solved it, maybe they go, "Oh, wait a second, I like that way. That's really good. I like that. It's an easy solve," and maybe you might use that. So that's where I'm talking about, like pulling out some of your stuff. In the video, there was only 16 dots. I screwed the dots up somehow, but there it is. But I thought it was a neat way to describe math. Okay. But there's a lot of processes. A lot of people do it different. Yes. All right. Here we go. We're back to this writing an equation. Wait, did we do this one? No, we haven't. We finished this one, right? All right, let's write the two equations here. Let's see if we can get fairly quick about it. You need a point and a slope. Kylie, you need a point and a slope. On both of these. Go ahead and write both So the first thing you need to do over here, I have to have f of x equals, and then you could just do some sort of squiggly line over here, and then write your equations in there. Now, I will tell you, I would like you to start from left to right. It doesn't matter, but it would be better if you start from left to right as you list them down from top to bottom. It makes it easier for me to grade, and it makes it easier for you to find your f of x's. Okay? So go ahead and find the slope of that first line. Find the slope of this one right here. Find a point. Put a point slope form. Write your domain restrictions. I'm going to give you practice right now. I'll give you 5 minutes. Good? Yes. Oh. It's like dark and bleak out today. It reminds me of that when I was in middle school. We had to read this story. These people were on another planet, and it, huh? You talking about? So I remember the story as it was rain. It rains all the time, and the sun comes out one day, and the kid got locked in the closet, and he needed to go out, and they came back and he was dead because he died because he lost it. He didn't get to see the day of happiness. So that was it. I don't remember who wrote it. A movie? There's a movie on it?
It's not a movie, it's a film. According to Lily, it's a film.
It's a film?
Great.
I just remember, this just reminds me of that. This is what the planet would be like all the time, 364 days out of the year, and then one day the sun comes out and the kid gets locked in the closet or something. The kids lock him in or something, they bully him and put him in, and then he dies, because he doesn't get the sunlight, so he's unhappy.
Every time it's like this, I was on memory of me in preschool. I just want to know how you got it too. And it was raining and it was really dark outside and I ate pudding.
You ate pudding? No, I don't remember that day.
Were you there that day though? And we ate pudding.
No, I wasn't.
Mary Beth was there. I think my mom.
It's kind of crazy that my brain, that we've read that same story you guys read.
Wait.
It's crazy. It's not like I've seen it. I hadn't talked about that in years. It's been decades probably. I mentioned that story. It just popped in my head. I was thinking about, I don't know. I watched Invasion last night. Maybe that could be why. So,
I watched this really crazy documentary yesterday with my dad about this girl in high school, like this couple, and there's this person like cyberbullying her. You need to watch it. It's your Netflix. And there's this person cyberbullying her for years, like telling her this crazy stuff.
It's her and her boyfriend, right?
Yes.
They're telling her crazy stuff. Yeah, I saw
you know
that.
who it was?
No, don't give it away. We want to watch Netflix. All right, stop. Don't.
Addison knew.
I'm glad Addison watched it, or she heard about it. All right, now.
I was watching it with Jamie yesterday.
Don't tell me. I don't want to know.
I told your mom about it.
I'm getting Netflix back here soon. We haven't had it in
My dad canceled mine.
7 years, so
He's canceled.
I'm getting rid of Apple TV. So Apple TV's closing up on the 21st of September. So I'm trying to watch all my Apple, like Invasion and Chiefs of War and all that stuff. And then I'm switching over to Netflix. Ted Lasso was good. I knew they're going to do a reboot, but I'm disappointed in the fact that they're going to reboot with the same characters. I thought it'd been better for him to like go in and start coaching like a pee-wee football or some other weird sport and become, you know what I'm saying? So, I don't know. All right. So let's go in here and let's take a look at the slope of the line on the left. What is that slope? It is not 2. It is a -2. Thank you. So I need it to be -2. All right? You need to make sure you're paying attention to your lines. It is falling, so this is going down. So that's why it is dropping, okay? And so you have -2, okay? Now, what point did you guys use? Most people use that one right there, which was x plus 3 plus 1. How wide is that line? You did what? How far left did it go, Kylie? X is less than or equal to -3. So that is correct. It is eating the -3. It is the largest it can be. So it's going to ignore all the smaller ones. Now, if you wrote it as interval notation, it is -infinity all the way to -3. The negative infinity, again, needs to be on the left side, and it is a bracket on the -3. All right, on the right line, the one on the right side, what is the slope? Yeah, it is 2/3, correct. And your point? You could use 5/4. It does make a difference which one you use. I went ahead and used -1, 0 there. But you could use 2/2. Okay, that's what ballerines wear. All right, I couldn't wear a 2/2. Mine was like a 4/4. So. The 2/2s were too small, so I had to go 4/4s. Ty Hayworth, he wore a 7/7. So. That was a football number back then today. If you ask him, he says, "Yeah, didn't you wear when you were a ballerino? Didn't you wear a 7/7?" Ask Ty that one. Football player. You know, got any football players in here? Yeah. That's Ty. Say, hey Ty, I heard you had Coach Love. He said you were a ballerino and you wore a 7/7. Not a 2/2. And he might laugh at you. All right. How far left does it go? -1. How far to the right? Infinity. Kylie, how'd you write it? There you go. Beautiful. Good job. Nice job. All right, moving on to the second graph.
I don't like doing the brackets and parentheses. And I know what I'm doing.
All right, looking at the line over here, again, you got to do f of x equals. Carter, what is the equation for that line right there?
Y equals negative.
Yep, so we're just going to write down the what? -3. No y equals. Okay? Remember, this is right here, Carter. That is your y equals, the f of x already. Okay, so we don't have to write that part. How wide is that line? Anybody? All the way to? What? It does not go to -3. -3 is right there.
Actually, it is actually. It said, I swear, it says negative negative.
Just count 2 over. It is how far?
It said that looks like a negative symbol.
It's a -5.
That looks like a negative.
It doesn't matter what it looks like. You should know. If that is -7, you're counting 2 over, guys.
I didn't mean to be. I'm sorry. I had a moment. Okay. I have a moment. Sorry.
All right, looking at this line here. Now, guys, this won't happen on a test or a quiz. We will actually give you the other point here. So that point right there is -1, 2. That would be a point, and I'll label that. This is kind of harsh to give you one that is kind of like weird in the middle. Okay, so when we're doing a test or a quiz, we will have points labeled for you. Okay, so you can see they're clean. And so this one right here, you can count up and over, and you're going to get 1/4 as your. Okay. So if you wrote it down as something other than 1/4, you're wrong. All right, now. So use a point. Doesn't matter which point. I think I'm just going to use this one. Five, 1. X plus 5 plus 1. And the width goes from -5 all the way to +1. Brackets on both those. Last but not least, it looks like it's got a positive slope of 1. Now, some of you guys may have went like this and just said x minus 3, and that is totally acceptable. And then we're going from 3 to infinity. If you wrote that as 1 and then just pick the point, that's fine. Okay. Questions? Is this too easy for you? I'm hoping so. I think we should go into. I think we should go ahead and do this one right here. Number 5. Graph in number 5. What do you call a fear of giants? Phobia.
Wait, that's actually really good.
It was kind of fun. It's fun to say. Phobia. All right, taking a look at this one right here. You guys know how to do it? Where do we start? I'll do this. I'll do you one better. You guys do it. Ready, set, go. Almost done with these notes. It's exciting until we get into the good stuff. This, hopefully, this is easy. Okay. Mr. Jones knows this.
What?
But the alien world is great. And he knows the name of the story. so sad.
Don't cry, okay?
But I mean, I remember it because it was so like impactful, right?
So.
As a young kid, were you hearing about somebody dying for the first time?
Yes. I think he just like comes out and says, crap. Yeah, just kidding. Like, wow, what a missed opportunity. No,
I think they missed it. They should have him out. I thought he died, but maybe I'm wrong.
Like this vacant shoe. Like in the closet?
Yeah, I think he would. They find him. They were looking for him, and they came in, and he was dead in the closet because he had died from what happened.
Are you okay? Yeah.
I remember waiting because I don't know. But it's been so. Of course, you're talking.
Yeah,
40 years ago that I read this story. So.
Do you like Interstellar?
Yeah, Interstellar's good.
You seem like a big Interstellar type guy.
Yeah. It's just been over talked about.
Bro, it is insane. Every time I watch it, I see something different. Wait, what did
you get it wrong? You good? Turn to 5. Guys, we got one. We got this page. Let's give you practice time. Ooh, can't have that. This function, so what has a rubber line? So one of these is going the wrong way. Where's this one started? Okay, and it's everything to it that is larger is a negative 5. That's right. This one says.
Oh, it didn't go down. Sorry. Don't hate me, okay? Don't hate me, okay? Because I cried. Wait, what are you guys talking about? Oh my gosh, I slept the whole time. No. I didn't gap for that one. No, I think it is.
So it rises that way. So down to 1.
Yeah, I don't like that. I think we all just looked at this work. I slept the whole time, so I didn't even know.
So again, this can be a negative.
I remember the book, but when it's like I don't remember. Hey, you guys remember me? Because I remember making
Right
now. Okay, but it's actually just. And Sarah.
This is your water.
When he was girlfriend and he held and she and her friend held in her initials and of course I was thinking about that earlier because we were talking about he's like really messed up and if you like never mentally developed past the 6 Right, so why was he like like her like little kid, right? She like always she it was literally that. She was like a Marvin Casey. Well, like that's where that's used. Her boyfriend in high school, she held him down and called her initials. Did like watching I like watch this work video on my she's in jail in Nashville. Well, Nashville. Well, she's in like the federal. What happened to that other one? Oh my gosh. Wait, was it still? I forgot to check. So did give this board to show us the picture. What of the ones? So one's gonna like go back.
You can see, no, that is this.
One of my friends, her dad, the lawyer, the same lawyer, and he said that apparently something, like when they show that, one of the jurors grew up. Oh my gosh, the camera guy wants to take a multiple times because the camera guy can't hold his jurors. Yes.
Alright, so when you're doing this one right here, this one starts at positive 5. 1, 2, 3, 4, 5. Then I have a rise over 1. Remember, this is negative 1 over 2. So it goes down 1 over 2, down 1 over 2. Remember, it can also go up 1 over to the left 2. So this would be the total line, but I want everything that is larger than negative 2. Negative 2 happens to be right here. It's a closed circle going this direction. So over here, these dots would not exist. Now, this one starts at negative 3, which is down here. Now, it's going down 1 over 1 as well, which is this way. Now, I've had a couple students who are working, and they were doing this, and they have a tendency thinking, oh, I need to go this direction. Aubrey. All right, now, this says what? What does f of x stand for?
Function.
It's a function. So it has to pass the what? Does that pass the vertical line test? So if your function doesn't pass a vertical line test, then you've got a mistake. Okay? And in this case here, this is saying everything less than negative 2. That is the other direction. It should have been an open circle going that way. Now, on a test or a quiz, I am definitely going to ask the question here, find me f of what? What would be a really good question for this one? Okay. What is f of negative 2? Why is it a good question? Because here at negative 2, there's an open circle and a closed circle.
6.
So it has to be a positive 6 as your answer. The open circle doesn't include it. Okay? That, I am definitely going to ask you a question like that. Okay? We'll finish the rest of them tomorrow.
Did you watch
What?
Megan Boswell?
Megan Boswell? No.
He didn't watch it. Megan Boswell.
Yeah, she was a murderer, so it didn't matter.
Oh, let me tell you,
She's a pretty evil girl in a mindset. Wouldn't accept her actions, I guess, right?